name's HETTIARACCHI. Today I'll be going through in this video I'll be going through the two vulnerabilities that I did find in our system, which is having insecure JWT, secret management, and also information disclosure in error handling. This is a microservice e-commerce platform designed to buy foods or deliver foods online. In this as you can see, the secret key is really weak, and also it is exposed in the application properties. So what happens when you expose a JWT secret token in this application properties? What it does is it's like having an attacker will have access. If an attacker was to have access to this key, he will be able to access data, account data, and delete or alter those data. So in order to avoid this, I did generate strong secret key, and I did store it in the environmental variable. So now the secret key is really strong, and also it's in the environmental variables, and also the other informations are also there in the environmental variables. So the attacker now won't be able to access any of these sensitive data. Moving on, the next one will be having sensitive data exposure by error handling. So what it happens is, for example, if a attacker were to input a wrong username and then the correct username and wrong password, it will directly tell that the password is not correct, and then the user can try multiple times because he knows that the user exists already. So by doing so, the attacker will be able to bypass the security by guessing the password correctly. In order to avoid that, I came up with custom exceptions which do not send the message directly. Rather, it will send statement request error alert, please check your input. This will prevent the attacker from being able to inject SQL queries by observing the outputs of the database. There are outputs of the database. This is mostly by doing so we can avoid excessive attacks as well as SQL injections. Thank you.
Hi, I'm Ashan. I'll covering my two contributions in input validation and OAuth implementation. First, for the missing input validation vulnerability, our EasyByte app was accepting any data users sent without checking if it is safe, like restaurant accepting random ingredients without checking if they are edible. In the previous code, as you can see, there are no input validations or whatsoever in the DTOs by which meant attackers could send malicious data and crashing our app or bypassing business rules. I fixed that by using Hibernate validate annotations using as not null, not blank, and for required fields, and email for email validations, and size limits for uh, length limits. I also added a global exception handler for centralizing error handling for clean user feedbacks. Second, OAuth implementation with Firebase. Originally, our login system was a simple username password login flow, which for forced users to create another password if the username or password was forgot. I implemented Google Authentic Auth through Firebase. When users click continue with Google, it will redirect to select their email address from there, and then it will validate the user and send to their dashboard. With that users will never share Google password with us. Firebase confirms their identity securely. This is the backend implementation what I did, and this is the front end implementation for Firebase. With that, input validation blocks malicious data before it causes damage, and OAuth provides secure, user-friendly authentication backed by Google's infrastructure. Both improvements significantly enhance our security posture. Thank you.
Good morning. My name is Siriwardhana, and uh, my IT number is IT22094568. This is my SSD assignment. So the first vulnerability that I have found in the application is the CSRF protection. So in the application, here's the here's the CSRF protection vulnerability code snippet. So in here you can see that the CSRF is disabled in this Spring application. So this allows the user to pretend as an authenticated user and send requests, uh, force non-users to send requests without the acknowledgement. So to fix this issue, I have added the CSRF token repository and force the application to use validate CSRF tokens at every request. So for every request that this Spring application receives, it validates the CSRF token before the request is sent to the controller. And the second vulnerability that I have discovered is the weak password requirement. So in front end, there are password validations, but if the users were to send a request directly to the backend, this scenario was not handled in the backend. So in the backend, previously there was no way to handle the validate the password, whether it was a weak password or a strong password. So I have added that component function to validate the password when the user is registering. So in the validate password function, what it does is it is checking for a regex pattern. So whether A to Z simple to capital are included with numbers, and whether it's more than 12 characters. So these two are my vulnerabilities that I've discovered, and these are the fixes that I implemented. Thank you.
Jayasinghe. I am doing the vulnerability fixes for brute force attacks and the insecure course configuration. So the brute force attack is stopped via the rate limiting feature and the account log feature. As you can see, for the logging and registration endpoints, I have implemented two limits: 5 requests for the logging and 3 requests per minute for the registration. And also the brute force attacks is limited by the protection, where 5 fails attempt for a particular user will block that account for 15 minutes. And then these features, as you can see, the account log feature will temporarily lock the account after 5 fails attempts, and the rate limiting feature will limit the request per minute and um, ask the user to try again later. And then these features will protect the site from unauthorized access to user accounts, and also the denial of service attacks due to large volume of requests. Also, the second vulnerability is insecure course configuration, where the previous API gateway allowed overly permissive course rules, which allowed malicious sites to send unauthorized requests to the site and steal user sessions. So this trigger course configuration protect the site from unauthorized access to APIs. Also protect the site from CSRF like attacks for the tags exploit from the site. So these are the two vulnerabilities I have fixed for our project, and that's all from me. Thank you for the time. Thanks.